Hello and welcome to LogRocket. Today I'm here with Tanner Linsley, who's the creator of the TanStack, which includes popular tools like React Query and React Table. And he's also VP of UI UX at Nozzle. How are you doing, Tanner?
Doing great. How are you?
I'm doing well and excited to have you on. So maybe we can first start by jumping into the TanStack, which I'm guessing is named after yourself. And this is a bunch of very popular open source tools in the React ecosystem. And maybe you could give us a quick introduction to some of them and what they do and how they help build great apps.
Sure. I'll start by saying I really hope that TanStack doesn't come across as really ostentatious. um,
No, I don't think so. And there's a fair amount of companies in dev tool space or tools named after founders, like the HashiCorp is, I think that's named after the founder, and New Relic is named after the founder. So,
I mostly just needed something that wasn't my name, but could be vaguely branded, so
yeah, no, makes
TanStack
sense.
seemed to work out. So I actually didn't make TanStack a thing until probably about 2 years ago. Before that, I was just kind of building open source just under my own name. And most of my libraries are still under my own name, but I'm trying to kind of slowly move things over to the TanStack branding. But yeah, if you go to tanstack.com, you'll see quality software and libraries for the modern web. And I have kind of a list of open source libraries. So mainly React Query, React Table, React Charts, and React Virtual are probably my four most well-known libraries that I currently publicly want people to use. I have lots of others that I work on and that I use personally, but might not be ready for prime time yet, or at one point were and are not anymore. So
And maybe we can start with React Query. So, yeah, what does that one do?
React Query is a data synchronization library for React. So if you've ever used a tool like Apollo for fetching GraphQL, it brings a lot of those same niceties and features of having a coordinator for queries, but without the necessity of using GraphQL. So really, it is an interface around promises. So anything that you can turn into a promise, you can use with React Query, including GraphQL for that matter. So React Query is just all about synchronizing data from your server or wherever you want really promises to your client and making them more accessible in a React ecosystem. You've seen a lot of people who they always start out building that little fetcher component, use state, use effect, and we all know that use effect is like the biggest foot gun created in React, but it's also really powerful. So React Query is basically there to help you not write that code over and over again. It's got all the major use cases of caching and deduplication, and it really, in a great way, it gets you away from where we've ended up as global state managers. So there's lots of tools like Redux and MobX, and even creating your own with React Context. If you're doing that to manage server state and server data, you're probably taking a step in the wrong direction now. That's where a tool like React Query would just kind of come in and own everything and make it bulletproof for you.
So, let's talk about it a bit more. Like, let's say I have a REST API, have a React app. One way I could get data from the server is like write some code that fetches data, sticks it in Redux. Every time I need to, update, maybe pull the server for new data, I have to write some logic that
Yep.
grabs that new data, puts it in Redux, and then my app will update. How does React Query improve upon that experience for a lot of like the common patterns you see in a typical REST based application?
Right. So you make a good point. Like we're already talking about global state, right? Redux. Everything you do with a global state manager like that is synchronous. So you are kind of converting these asynchronous events that you're getting back from the server into these synchronous events and trying to keep that state up to date. So the first thing React Query is going to do is get rid of the need to manage that on your own. There's no more, set loading, set data, set error. All of that is just handled for you. So it is a state machine. Under the hood, it is a state machine that's managing all of that for you. So that's kind of the first great thing that it's going to replace. So you're no longer managing your own state. The next thing it's going to do is it's going to cache that response. So all that data. Same way that Redux would make it available through your entire app, React Query also makes it available through your whole app. So anywhere that you call that query again in any component as many times as you want, it's all going to get deduplicated into one query. That's not necessarily something new, but it's expected functionality. I have to mention it. And the next great thing about it is, usually people stop after they, do the on mount event. Everybody does this with Redux or even React Context. You mount your component, you kick off the fetch, you get the data, and then after you get the data, from there on out, updating that data through your application is a very manual process that's very granular. You have to say, oh, hey, they remounted the component, or they left the page, they came back, we remounted again. You have to fire off an event that's going to refetch that data. And you have to make sure that that fetch happens in the background so that they're not seeing a loading state every single time. So while you can still be very granular with React Query when you want to update, most of that event lifecycle of keeping your data up to date is just built in. So there are a lot of automatic dispatched events through React Query to keep that data up to date based on user interaction. So you can customize that user interaction and those events a lot, but out of the box, it will automatically keep your data up to date as you refocus the window, as your network goes on and off, as new instances of the query appear on the screen and come off the screen. So there's not really the need to manually keep that data up to date anymore. It makes it feel like a subscription, almost like a WebSocket, but without WebSockets. And it's not even using interval polling either. It's not on a timer. It's user input based refetching.
Interesting. So it sounds like it kind of is smart enough to know when a user interacts with a page, or you mentioned when the page is refocused after a period of being unfocused. Those are the triggers to fetch new data versus just saying naively, like every 30 seconds, fetch the data.
Right. And you can still do that. If you want to put it on a timer, you can. There's refetch intervals built in. And if you want to hook it up to WebSocket events, you can do that too. I do that at Nozzle. But out of the box, it's designed to be very friendly, very. It's also very aggressive with how often it keeps the data up to date, but you can kind of tune that up and down as you need it. Something that's unique to React Query is the concept of stale time on your data, or data staleness. And what that means is that out of the box, React Query is just kind of going to always be refetching data from the server a lot. It's going to err on the side of, let's keep this up to date as much as possible. Versus sometimes you don't want to fetch the data that often, either because you have API restrictions, or you just don't need to, or the data is not changing. So if that's the case, you can set something up called stale time on your query instances. You can say, I'm okay if this data is stale for this amount of time before you refetch it. You can set it to 10 seconds or 30 seconds, or you can even go all the way up to infinity if you just don't want it to ever refetch again. A good example I give people is a Pokemon API is probably not changing that often. They're kind of locked in for a long time. So you wouldn't want to be refetching that all the time. You could set it to infinity. But, a task list that you could be potentially sharing with other people, probably don't want that to get stale very often. So I would just leave it at 0. So that's kind of the concept of stale time. And um, like you said, it is intelligent enough to know what data is being used on the screen at any given moment. And another unique feature that it has is that um, if you have 5 components that all subscribe to the same data, you'll have 5 instances of this query, but still just sharing one entity. But if all 5 of those instances become unused, like if they unmount and drop off the screen and you're not using them anymore, React Query will mark that data for an eventual garbage collection. And by default, it's about 5 minutes. So if you have an app that your users are moving around a lot of screens and loading a lot of data into memory temporarily and then moving to other screens, eventually you would run out of memory if you were loading a lot of data into it. Uh, Maybe every app doesn't run into this issue, but I do a lot of data visualization and querying from in our products, and that data can be very heavy sometimes. So that 5 minute cycle of recycling the memory and keeping things up to date, that's just built into React Query for everyone who uses it. So it's pretty neat.
And React Query, does it have an internal Redux-like store where data is cached? Like I think I've used Apollo before, and I want to say they can integrate with Redux and actually store data in the Redux store. Like, is there something similar with React Query, or is it a different model?
React Query has its own store model internally. It's you can kind of see it a little bit as you create the query client. So one of the first things you do when you use React Query, you create a query client and you provide that to your application. That query client is where a lot of that state lives, and it's not just state for the queries; it's also state for any potential mutations that are happening as well. So it's a very specially designed store that's optimized to work with events around React Query's purpose.
In terms of like debuggability, can you use like one of the various Redux logging tools or debuggers or something similar when you're trying to debug issues and see like what the state was at a given point in time?
No, we did look into something like that early on as a way of integrating, but at the end of the day, it the event system internally was pretty custom, and if you're just logging out those events, it got really really noisy. You can imagine with refetches happening automatically all the time, just a constant stream of those text or JSON dumps of those events would kind of get heavy. Instead of going that direction, we kept it internal uh, and proprietary so that we could build dev tools around it. Uh, the dev tools for React Query are just built into the library. You just import them from React Query slash dev tools, and the dev tools are just a React component right now. You render them on in your application, and they just kind of mount at the top of your app. And the dev tools are really unique because instead of just kind of pounding you with all of these events, it takes everything and turns it into more of a GUI. So there's a lot of color encoding and status updates going through these dev tools that you can actually see through these color indicators and status indicators on each of your queries, which ones are refetching when and how, if they're stale or they're fresh, or how many observers on the page, how many components are observing that query. Um, and of course, the things you would expect from DevTools as well, like inspecting, the data payload and the query settings for that query and manually triggering things and removing things. So it's they're much more involved and um, like holistic than say an integration with something like Redux DevTools.
Got it. Moving on, curious to learn a bit about some of the other tools in the TanStack. React Virtual is one I'm particularly curious about. Could you give us a quick overview of that?
Yeah. React Virtual is first and foremost, it is a library for doing virtualization. If you don't know what virtualization is, it is the concept of windowing lists or windowing elements in your browser that might be very long. So if you have a list of 100,000 or even a million items and you want to scroll through those items in your browser, you can't render all of those items all at once into the DOM, or the DOM will probably choke. So React Virtual makes it so that it only shows the items that are within the viewport or within the bounds that you have set. And as you scroll or move through those bounds, the items move, kind of move in and out of that list, making it look and appear as if it's a really, really long list, but really there's only a few items rendered at a time. So that's virtualization, and that's what it does. There's other libraries that have done this, before and really well. React, let's see, React Window, and there's another one. Brian Vaughn has done a lot of work with these virtualization libraries, and they're great. One reason that I created React Virtual was that I needed a headless solution. And if you don't know what headless is, it's kind of a modern, newish term in the ecosystem, but that means that it doesn't render any markup or styles for you. It's merely just the logic. If you were to go to react-virtual.tanstack.com and go down to some of the examples, you'll see that the way you use it is you just call use virtual. It's just a hook, and you provide it some basic information about the virtualizer you want to create, and then you then take that information and the event handlers and the props and styles, and you apply them on top of the markup and styles that you are using in your application. There are a lot of benefits to doing that. We can talk about those if you want.
Yeah, I'm actually. It's an interesting topic. A couple of years ago, when we were first building the MVP of LogRocket, in our UI, there's a component where it's basically our recreation of the Chrome DevTools log viewer, and so you can have tens of thousands of log messages that need to scroll. So it's a good use case for virtualization. And I used Brian Vaughn's React Virtualized for that component, and definitely kind of pushed up against the limits of not necessarily of that component, but just got into some different edge cases. And shout out to Brian, who was super helpful on the GitHub issues, helping patch bugs and answer questions. But one of the things that traditionally can be tricky with virtualization is like dynamically sized elements, since the goal of the virtualization component is to calculate, okay, what's in the current viewport. And if you have a bunch of elements that can change their heights, that can cause some trickiness. So I'm curious how you handle that.
So React Virtual can do kind of all three styles um, of item measurement. So it does have a static style, obviously, where each item is the same height. There's a variable style where each item can have a different height, but it's still hard coded, set to never change and known ahead of time. And then there's a dynamic style, and the dynamic style is very unique. This challenge is difficult, and React Virtual is by no means perfect, but I think that its approach is pretty cool. So out of the gate, you need to at least give React Virtual some type of hint about how big you expect these items to be. They can all be the same size, but just kind of roughly, and just take an average of the size really is just fine. I kind of always go with about 40 pixels tall because that's about how most lists are. But from that point, every time you render an item, React Virtual has a backing mirrored store of each item and its size, right? And it's full of gaps. It's full of gaps and unknowns, and that's kind of where the size estimation comes in to give you some type of scrolling that you can use out of the gate, right? But the cool thing is that we use React's ref callback features. So if you've ever used a ref in React, you can pass it a use ref object, or you can pass it a function, and that function will give you the element the underlying element, DOM element, and call that function for you anytime that it mounts. And this is really helpful because we can basically just give you a ref measurer utility, and you can take that and place it on each item that you're rendering. And React Virtual will know, oh, we just rendered item, 150, and in a request animation frame. And honestly, I can't remember the implementation details, but we measure that item and all the other items that are coming through. And as we can, we update that backing model with all of those heights. So you'll notice if you go to the dynamic scrollable version, the scroll bar will be kind of this big when you start. But depending on how those items actually get rendered out, which in the example they're totally random. Like it's just like, oh, it could be any size between these pixels. As you scroll down the page, you'll see that scroll bar kind of flex up and down, get bigger or smaller because of how the items that you have rendered are changing that backing store and changing the total height of the virtualizer. And because it's headless, we don't have to manage all of those styles in React Virtual. We just tell you, here's the total height, how it's changing, and here's where you are in that window. And it kind of just
Got
works.
And so when you say measure, that's like you have an item, it could have any height, and you don't know the height until it's rendered in the DOM. And the browser, especially like if you have fonts or things like that, you could have overflowing text or like
Yep.
different things like that that make the height unknown until rendered on the
Yep.
DOM. You use the useref callback and then just measure how big is this actual element once the
Right.
browser renders it.
Yep, and we try and do that before Paint too. So, if you were to click the scroll bar immediately halfway down the screen, those 10 items that kind of pop into view, they're all going to render with that estimation size first. So it might even render, 20 items because it thinks they're all 20 pixels. But for each one of those individual line items, it's going to measure them really quick and figure out what their total height is and then readjust before the paint happens.
And this is really getting into the edge cases, but one that I remember being pretty fun to deal with was if you have elements that can change height. Like for example, in our log viewer, you could, similar to in Chrome, you can click on if an object is logged, you could click on it and it will expand.
Mm-hmm.
How are those handled with React Virtual?
So at the bare minimum, we provide you some callbacks, some functions that you can call to, like, hey, I want to manually invalidate these measurements of what's there, and they will get remeasured immediately. And that invalidation function of, hey, and remeasure everything is pretty darn performant. I've seen people who, my suggestion would be not to do animated expands in virtualizers, uh, because you can just expand it and then call that function, and it's very synchronous. There are people who want that animation expansion, and so
Right.
I kind of just say, well, then you need to hook into that animation loop of whatever is doing the animating for that, and call the invalidator, throughout that animation, and that it works really well. So it just kind of depends on how complex you want to make your virtualizer. What your use cases are. Um, yeah, I can't think of a good use case of why you would need a virtualizer to be animated height, like the items. But someone's going to come up with it, and they're going to say it's important enough to us that it needs to work. So yeah.
Yeah, that is always true when you're building something, and it's I guess it's a good sign when people in the community come up with use cases you didn't think of and push the boundaries of what you're building. Um, I'm curious when you think about these different tools that make up the TanStack. Like, are there any kind of themes that unite these or better together kind of aspects of the different tools you're building, or how do you decide what to build and add to this stack of tools?
Yeah, the we could talk about a kind of inception first, I guess. Is I usually don't build a tool without doing a lot of other things first. One of the main reasons that I would build a tool is because I need it, first of all, and that need comes from the other non-open source like projects and companies that I work on, and mainly Nozzle. Nozzle is my startup. I started it with two other guys, and we've been going for 8 years, and we've been solving some very very difficult problems with big data and reverse engineering Google search results essentially, and providing that data back to whoever wants it. And with that, comes just a lot of challenges for a modern web app. And these are challenges that may not be super hot right now. Everybody seems to be talking about SSR and hydration and the things that might affect a majority of the web in terms of performance. But everything at Nozzle is kind of on the other end of the spectrum. Everything's behind an authentication gateway. We're not going for first page load speed. A lot, it is very much an application that lives on the web, and with that, we've had to tackle different problems. One of the very earliest ones was tables. Like I just could not find a good table component for the life of me, and I found some, but they were just rigid. They didn't let me do things not just the way that I wanted, but they didn't give me proper inversion of control. You know, and so I set out to build React Table. That was one of the very first libraries that I built, and I built it for Nozzle because I needed it. And I built it until it matched my use cases in Nozzle, and then I released it and stopped. And other people took it off from there, and I kept improving it. And the same thing happened, with React Form and even React Query. I needed those because I was kind of bumping into the ceiling on some of these concepts in Nozzle. I I wasn't getting enough data updates in Nozzle. People were shared. We have shared workspaces and shared teams, and people are saving things all the time, and objects are changing. And I'm like, Redux is not cutting it. And so I found myself writing all these events, to keep things up to date. Pretty soon, I had this custom thing, and I was like, this is a big problem. I'm going to release this as a library, and that's where React Query came from. And the same thing with React Virtual. I needed to virtualize some things that, you know, I needed to own the divs and the styles, and I needed to know about the implementation of said virtualizer. And bless Brian's soul, I love his work, but that's not how his components were built. And I'm sure he wasn't ready to, just completely revamp all of his virtualizers for this one use case. So I like to vet libraries in the ecosystem really hard. I would rather not have to build something to proceed with my blockers at Nozzle. Uh, it just saves me time. But if there is a situation where there's a gap and it's going to help everyone if I just build something, that's kind of why I build the tools that I do.
And what has your experience been like open sourcing these tools? Some like React Query, I mean, all of the tools definitely getting some strong traction in the community. Have you found it kind of, has the decision to open source generally been one that is kind of worth it from a amount of time you have to invest versus the returns you get from having the community members being involved, fixing bugs, finding edge cases? Or have there been any cases where you're maybe feel like you shouldn't have open sourced it just because you haven't had the time to invest as much as you should?
Most of the time, it's been worth it. We're a very small team. I mean, up until just a year or two ago, I was the only front end developer at Nozzle. I was the intern and the VP, kind of playing all the pieces and doing all the roles. And it was hard because I didn't have a team. I didn't have people to help me or bounce ideas off of. So open source was kind of like my adopted team, so to speak. I adopted the internet as my team, and if I could convince people to use these tools and help me make them better, I would essentially be outsourcing and exchanging, that for some work. And it proved to be very helpful. Like React Table got a lot of support. React Query has a ton of support now. And at the end of the day, Nozzle is my biggest concern right now, and it's doing great. I'm very confident about all of the querying in Nozzle because of all the great help that I've received. So it's definitely been worth it. It doesn't mean that it's always been worth it for every project. There have been some open source libraries that I've built that just kind of they either don't catch on because they're not necessary or because competition is fierce, and I'm a one man show with a full time gig going on. One of those examples was React Static. I built React Static because this was back when Gatsby was getting started and Next.js was getting started, right? And I kind of threw my hat into the ring with React Static as this static site generator um, that could do route-based data fetching. It was kind of ahead of its time a little bit, to be honest, because everybody loves route-based data fetching now. I just didn't have the dynamic part, that Next.js has, and um, it was really cool. But at the end of the day, it was merely just to build Nozzle's marketing site because I didn't like the tools that were there, and that's not a really big use case for Nozzle. We didn't really want to maintain it. I didn't want to maintain it, and honestly, when you pitched it up against Next and Gatsby, who Next has this awesome company Vercel behind it, right? Who they have a lot of cash, a lot of people that they can throw into Next, and they're doing that, and you can see how it's paying off, right? I knew that was going to be the case. I did not want to try and compete with that. And then Gatsby, like kind of in a similar vein, like they raised a ton of money and they still have raised a lot of money and they're throwing a lot of that into the Gatsby open source project. And I'm like, I can't compete. This I'm a one man show and I can't compete against, these 20 or 30 developer teams who are all contributing to these projects. So situations like that where it just kind of makes sense to just kind of let it die. And I didn't let React Static die. I handed it off to somebody who was going to appreciate it and take care of it more than me. Um, and another great example is React Form. Like React Form it was early in its time and some people still use it. I use it at Nozzle, but I can recognize that like there are libraries like Formic and React Hook Form, uh, and React Final Form. Those are all really, really great form libraries that they have a lot of features and a lot of great things about them that I don't have in mind. And so I just kind of quietly decided to retire, that library, at least from pitching it to people and trying to get people to use it because it's, I'm not doing open source to, for the attention. I'm not doing it for, to stroke the open source ego, as some people say. It really is just a means to an end for me to solve these bigger problems, and hopefully problems that other people are experiencing as well.
You mentioned before, you're building this company Nozzle. You've been working on it for the past number of years, and you said that you pull data from Google and do a lot of interesting big data stuff. Just curious to learn a bit about Nozzle. I'm not super familiar with the product,
Sure.
so maybe you could give a plug for what you're building.
Yeah. If you want to learn more about it, like you can go to nozzle.io. That's our website. But essentially, are we are reverse engineering Google search rankings at scale. What the people in the SEO community call that is SERP or rank tracking. And so we are very much an enterprise scale SERP or rank tracker. What that means is that you come to Nozzle and you enter in keywords and phrases, things that people would search in Google that are similar, like in the vein of your business and your marketing department, right? We have people with 100 keywords that they want to track, and we have people with tens of thousands of keywords that matter to them. And those keywords can be modified with languages and devices, whether you're on a phone or a tablet. And they can be based on like geolocation or zip codes. Like there's a lot of permutations to these searches that people are doing all over the world. And we've built a manager around all of that keyword tracking and scheduling and very advanced scheduling that you probably won't see in the SEO rank tracking community. We're kind of bleeding edge in that way. And from there, there's like the whole admin side that we have a whole backend team. Like we are all Kubernetes Go, very microservice driven, just constantly crawling and uh, categorizing. And we maintain so much data. I think we create a couple terabytes of data every week that we're throwing into technologies like BigQuery and Vitesse for MySQL. So there is definitely a big data problem that we have on the back end, and our engineers are doing a great job of solving that. And then on the front side, on the front end of it, there's like, okay, how do we take all of this data and all of this complex keyword management and possible, reporting tool, like reporting scenarios, and make them all accessible. And you know what? That kind of reminds me, I didn't even talk about React Charts. That's another one that I built because I needed it in Nozzle. So
Yeah, well, I'm happy to hear about it. Is that yeah, maybe you could tell us what React Charts does, or kind of how it improves upon some of the existing chart libraries.
yeah, I'm trying to think of how I can frame it. I I guess I'll start by saying like I started with D3 and tools like D3 and C3, and I learned a lot of those, and I even contributed to tools like Crossfilter that were built to integrate with kind of D3 visualizations. And then from there, this is probably about 5 or 6 years ago, I worked on Chart.js.
Mm-hmm.
I worked with Everett Timberg, actually. The two of us, we rewrote Chart.js to version 2. So I'm not super affiliated with it publicly anymore, but you can still go to the contributors there and see some awesome contributions from me to Chart.js. Like I loved Chart.js for a long time, got a little too familiar with the Canvas API. I don't really enjoy working with Canvas API anymore. And when I got into React, I kind of moved back to SVG, because they're so like they work together so well. And I was like, oh, there's got to be some great tools out there. I looked into tools like Nevo and VisX and their React Data Viz, another one. I can't remember what it's called, but I tried a lot of these tools, and they're all great. They either tend to be more on the spectrum on one side of like, hey, we're going to give you a lot of low level tools, and you still kind of have to build your own data visualizations, or they are like very drop in, kitchen sink. Here's a charting library that you just say render this chart. And I liked both of those for different reasons. I am definitely partial to libraries for charting that kind of take care of everything for you, because I know I'm all about headless and the implementation details and like making it like making it so that you can control everything. But I don't think that that's the right approach for chart building. It is for data
Yeah.
visualization that's custom, right? If it's custom, go with VisX, do your D3 thing. But for 99% of us who we just have data and we need to get it to the user and show them, you don't want to have to think about data visualization. It is complex. It's not top down like you think it is. There's graph dependencies under the hood, and there's so much that goes into building great charts that it's not something I would even want to be headless and wire up on my own. So that's why I built React Charts. It's just a component chart. And you say, here's a chart. And I narrowed in the scope really small to make sure that it was doing the best that it could at one thing. So it only does XY charts. There's no pies, no radial charts or anything like that. And I have my own opinions about pie charts, but they're not, I don't think they're that useful or great. So don't use them. But like it only does XY charts. But by kind of locking in to say, okay, this is the way that we're going to do it, and we only do XY charts, and we're very friendly with React. Now you can just kind of dump a chart in there with some data, and you get all these great features out of the box. You get, automatic axis generation and tooltip generation. There's cursors that show up on the axes, and there's what else is there? It's totally responsive, so it's hyper responsive, if that's even a term anymore. But locally responsive to the component. So you just drop it in and it will fill the space that you give it by default. I get so angry with charting libraries that are like, oh, here's a way to make it responsive. That's it's no, it should just be responsive out of the box. And things like automatic margin calculation for your axis labels and automatic tick rotation. These little niceties that take so much work and effort, even if you're doing your own D3 visualization. Like they're so hard to do, and I've been working on them for probably like 3 years. And I finally feel like it's in a place where I can let people use it. So that's why I built React Charts, and now it powers all of the charts on Nozzle's dashboards. We have in fact, if you go to the examples on React Charts, you'll find one that's a stress test. It's like at the very bottom. That stress test example is there to essentially proof of concept if it will work in Nozzle. Like we have, so many charts on the page at any given moment, and they're not just like static. They're moving around with resizing, and they have like linked cursors so that you can kind of keep your place across charts. Some of them are tiny little Spark charts, and some of them are huge. So uh, it's definitely built for a specific use case, but it's really good at what it does. It's currently in beta right now because I haven't written the full documentation for it. But I'm using it in production. Lock it into the specific beta version, and you'll be okay. But it seriously is a fun tool.
So tell me, what are you most excited about in the future in terms of improvements to the TanStack tools that are on your roadmap?
Um, React Query is pretty stable. And we're getting some few contributions here and there, and which reminds me, I should give a shout out to my other maintainer, TK Dodo, Dominic Dorfmeister. He's a great maintainer, definitely in it for the long haul, and he's a great teammate. And if anybody appreciates his work, they need to go sponsor him on GitHub. I do, and man, what a fantastic developer. He has a great blog too that we recently just integrated into the docs, talking all about best practices for like React Query. So go check that out. tkdodo.eu, I think is his blog. As far as improvements to other tools, I don't have any big major features planned for any of the other tools that are currently out. But I do have a new tool that I'm working on that it's not a secret, but I'm definitely not like marketing it a lot. But it is in the routing space for React. I know that is like a crazy kind of weird space to get into because of like there's tools like React Router that just kind of
Yeah.
they just own everything, And React Router is wonderful. I use React Router in a lot of places. But I'm working with some new concepts around enterprise routing, mainly around building these real, like Nozzle, a very complex application that has a lot of state and a lot of schema and rules and types that are kind of built into the routing of your application. There's a lot to be. React Router does a lot for you that is just wonderful if you're just looking for a client side router. And I know they're working on Remix, and that's kind of the backbone of Remix, which is really cool. But going into the purely client side realm, where there's just a lot of state encoded into the URL, there's definitely some areas that are left to be desired. And I have some proofs of concept out. I have a React location library that I'm working on right now. It's definitely not something I would suggest you use unless you want to just kind of try it out for fun. But that's going to be kind of a new home for some of these new concepts that I believe maybe are not as prevalent or widespread as the necessity of React Router. I will keep using React Router for specific projects, that need it. But for the very, very small amount of big applications out there that are doing like a lot of enterprise level routing, I would like to build a tool that's going to make some of those things easier. So that's kind of on the horizon. I'm currently using a very, very internal alpha build of that React location library at Nozzle, and it's turning out really, really well. So stay tuned for that one.
Great. Well, Tanner, thanks so much for joining us today. It's been awesome to learn about Nozzle, and of course, all the open source tools you're building. We will put some links in the episode description to your different tools, to Nozzle. But otherwise, yeah, thanks so much for joining us.
Yeah, you bet.